This is the story of Ampleforth, a little program whose sole ambition in life was to become a live literate editor for Newspeak. But now that it has achieved that ambition, it actually is exceeding expectations and can turn into a lot more than that. So when Ampleforth was little, all it could do was show little evaluators embedded in a web page. But these were live evaluators. And so when you got a result, it was already capable of doing more interesting things. It was precocious even in its youth, because these results were links, which would get you to, say, an object inspector on the result, which could then show you the class of the result and perhaps take you to the entire ID, all embedded in your web page. So that was nice, but it was convenient to do these things more directly. And so this blog post written some years ago shows you that not only can you have the evaluators, but you can embed the entire IDE or a class directly in the presentation, and then you can browse it and look at methods and things like that. So this is good and well, but Ampleforth still had a fatal flaw, as it were, and that was that it was not compositional. By compositional, I mean that you could embed a Newspeak widget in a document, but you could not embed a document in a Newspeak widget. And if you could do that, then things would actually compose, because you could have a widget in a document and a document in that and a widget in that, and it could go to any depth. So that would allow you to do things like, for example, this help feature, where inside the widget that's showing the presentation, we have its help, which is defined by a nested document, which has in it live widgets that illustrate how the different features of the UI work. So for example, this menu is actually live and works like the real menu, and we can click on it, and it will show us an object inspector on the actual widget that's doing the presentation. And if we look at that widget, we'll see it has a help text method, and in there we'll find that there is actually HTML code for the help embedded there, and that's what defines the help that we see. And to prove that that's true, we can go and type some rubbish in here, accept that, go back and look at the help now, and yeah, blah blah is there. Isn't that great? So that was good, but Ampleforth had still not achieved its ambition, because it wasn't yet an editor. But now it is. And to see how that works, there's a little toggle here. We'll open it, and we see that Ampleforth is actually a two-view editor. It shows you a WYSIWYG view and a markup view, and the markup, which is HTML, is synced live to the WYSIWYG and vice versa. So if I keep typing, you'll see, if you look down here, that the markup updates. And by the same token, if I type in the markup, then of course the WYSIWYG updates, because the markup is the model for this editor. Now, Ampleforth can still do the live literate thing that it was designed to do. So here we have this counter, and it's live. We can increment things and decrement things and reset, and all that stuff works, right? But we're really after live literate programming. And so here's the definition of the counter. It's basically a method presenter embedded in the slide, just like the counter is embedded in the slide. And if we choose to change that definition, for example, we decide that increment is much too clear and we want things to be obscure because we're real programmers, and we accept that change. So now the counter has changed live in the slide, but it's maintained its state and continues to work just as before. So that's nice. How does that all work? Well, if we look at the markup view, we'll see that there are these divs here that are of class Ampleforth, and they basically define what widgets we're going to embed at that point in the document. So they have a name, and the name indicates which widget we're going to use. What the name is really is the name of a method that we're going to invoke, which should return us a live widget that we can actually insert into the DOM at that point, and therefore have it display. So basically what Ampleforth needs to do is to find these things, find the name, and call that method. And of course, who does it call it on is the question. So there's an option here to inspect the document object, because really what happens is these methods are sent to an object representing the document, and it provides essentially a live scope for everything you write in the document, which you can refer to things that get computed. And if we inspect it, we have an object inspector. It still shows us the rendered document, but that's just one view. There's also a basic view, which just shows you that it really is just an object inspector with a list of variables and so forth. And inside the object inspector, we can look at the class in context and see that indeed there's a thing called a counter, a method called a counter, which will return us a view on the counter. If we evaluate counter, then we have an instance of counter presenter, which is the class that represents a view of the counter in a sort of model view controller kind of way of looking at the world. Now, if we want to know more, the counter definition, the method that we were looking at, it does a bunch of stuff to create a method presenter, and ultimately it's relying on this class counter UI. Evaluate that and look at the class counter UI. Well, it turns out to be a class that has in it counter presenter, which is the view, counter subject, which is what you'd think of as a controller, and counter, which is the model. It's again a full MVC thing, which is overkill for such a little thing, but the point of the counter example was to illustrate how the UI framework works. Now, moving on, we can think of what happens when we get rid of all this text and we only have, say, the counter. Well, then we have an app, a little GUI thing, right? So this is really not just an editor, it's a GUI builder. And this leads us to this idea of docucentric programming, which I'll explain right now. To illustrate this, let's build a counter now in the document. Actually build a counter application. So if we look at the original counter we had, it had a value it was displaying, and there was an increment button and a decrement button and a reset button. And now there's this little feature here called Make It an Amplet. An amplet is basically a live embedded Newspeak widget in a document. And if we click on that and on increment, and this will already work, right? And we go here, and that'll take it back to 0. And if we look at the markup again, we'll see that, of course, now there are these Ampleforth things inserted, just as before, but they've been inserted interactively. And we'll do the last thing and add the reset button, and you'll see that a new one named reset was inserted into the document. And of course, this is a working counter. And it works because there is code in the document that implements these things. So if we look at the document object and look at its class, there is a method called counter value and a method called decrement and increment. And so what the Make It an Amplet button did is took the text that we inserted into the editor and used it as the name of an amplet, which would tell it which method to call and get the right GUI element. So that's great, but this has other advantages. For example, if we decide that we didn't want it to be a row, we wanted this counter to be vertical, right? We can go and do that simply by editing the text of, if you will, of the document, but it's still a perfectly working counter. So if we compare this to the other version, you see that you don't actually need to know about model view controller or a lot of UI framework sort of conventions that you typically need to. It's a lot simpler. It's also live. It's open during construction, right? As you build this, it's continuously working. You don't actually have to go and write an app and then start it up and see if it does what you want and all that kind of thing. But of course, it's sort of a naive way of doing things, because if we go back and look at our slide, right, it's unstructured, right? The counter variable is right there. There's no model separation. There's none of that, which is an advantage for the early user. But if it was a more serious app, maybe we want to do it differently. And there's nothing preventing us from evolving this code now that we have it and taking those methods and separating them out into new classes, because the whole IDE is available here. So we have this idea that it's a general programming model where you start with an editor, and the GUI and the GUI builder are the same thing. It's modeless. They change as you edit. And that basically is also a complete IDE. You could do a computational notebook here very easily, or you could do something more general, like a spreadsheet or what have you, right? You have a complete development environment, but it has this low floor that you can start by just editing text, and then you can learn to insert videos or images or GIFs or whatever, and then maybe there are some ready-made buttons that will do things for you that you and eventually learn that you can make your own and how to program them. And so there's a relatively smooth path here from not knowing anything to full, serious programming. So what are the design principles that make all this work? Well, the most important, I think, is the idea that the markup is the model. That gives us all kinds of advantages. It's a language, it composes, it's human readable, it has semantics. We can manipulate it, metaprogram it, right? We can search these structures, we can generate new programs. And pragmatically, if there's anything that we haven't built into the UI, and there's plenty that's missing in the UI right now, we can get it done because we're relying on a very general and powerful markup language that's already there. Now, of course, this has to be a true hypermedia editor, because it has to be able to build and represent and embed computational media, not just rich text or images or videos or audio, right? It has to be able to do arbitrary things. That's also very important. And it has to be scriptable, right? We have to be able to code these things with a full general purpose programming language, and we want a live, fully reflective one, so that whenever we make these changes, they immediately get reflected, as we saw when we edited the counter definition, for example. And the markup has to be reified in some way, accessible from this programming language, so that we can manipulate it and metaprogram it. Last but not least, this has to be self-hosting, right? It's not enough that we have this nice scripting language for building things in the editor. The editor itself should be written in this same language, so that we can make arbitrary changes to it, and there's no sort of ceiling for the kind of changes that we want to make, or the control we want to exercise over the editor. So that's really all I wanted to tell you at this point. There's some ideas here for discussion, but I'll wait and see what questions we get.